Welcome back to the lecture 10 part 3 where we are going to talk about the Magnum wheel drive. So already I gave the introduction in the last part. So now we will actually take the Magnum wheel drive and we will try to address first of all. So what we wanted to do this simulation. So for that we will take this equation what we have derived in the you can say lecture what you call 8. So this is what we have derived in the lecture 8. So this particular equation we will use it. Even the small glimpse I have given in the part 2. So right now we will see what our interest is. So we will actually try to see if I want to move this vehicle in forward, what's supposed to be omega 1 to omega 4. If I want to move this vehicle in lateral, what I supposed to do. If I want to actually rotate the vehicle, what I supposed to do. So for that what I am trying to do, I am trying to take one blank page. So I can actually rewrite this equation. So in the sense what I am trying to do is actually you can see. So if I write u in the form of omega 1, omega 2, omega 3, omega 4, this would be a by 4 in the sense omega 1, omega 2, omega 3 plus omega 4, right. So then the other equation v is actually a by 4 where omega 1 minus omega 2 plus omega 3 minus omega 4. So you can actually cross check whether we have written right. So this is the case, right, 1 minus 1, 1 minus 1, right, that is what I am rewriting here. So similarly what I am trying to write the r, which is I can write a by 4, which is actually you can see here. So what it is then, it is actually minus 1 by d minus L omega 1, then what you can see that minus 1 by d minus L omega 2, you can actually cross check. So this is what we have derived. So then what we have taken, I think I am going inclined. So 1 by d minus L omega 3, then 1 by d minus L omega 4. So this is the three equation which we derived based on what you call this W into omega matrix. But what right now I am interested is if I want to move only forward direction, what would be the scenario? If I want to move in only you call lateral direction, what would be the scenario? Or I want to rotate clockwise or anti-clockwise, or I want to rotate clockwise, what are the options? Let us see the first one. So where u would be some value, but these two supposed to be 0. So I am just using in a different color. So this supposed to be 0 for case 1. So the case 1 what I am trying to see, so the v equal to 0 and r also supposed to be equal to 0. Then what one can actually see, if I actually take omega 1 to you can say all, just for understanding I am taking all are actually omega. Then what you can see, the u would be some positive which is actually a by 4 into 4 omega. So obviously it is a omega, right. So this is what you obtain as a u. But when you think about v, so what would happen? So omega 1 and omega 2 will go in the sense you can see omega minus omega plus omega minus omega, in the sense what you will get 0, right. The same sense you apply into r equation. So this would be positive, say these two would be minus of omega and these two would be positive omega. So you will get r also 0. This is not a difficult thing, where omega 1, omega 2 and omega 3 and omega 4 all are positive and which are actually same value, then you will move in a forward, right, that is not a issue. Now the issue is actually if I want to actually have something else. So what that means, so I am actually interested to see whether the vehicle is go either upward or downward direction. Now we will take as upward direction. So the v is supposed to be positive where u would be 0 and r would be 0. You recall the equation what we have actually taken. So what the equation we have taken? So we have taken these equation, right. So in that case, so this supposed to be positive means what you need to know. So you can actually take two combination where I am just rewriting that equation. So v is actually omega, I am just taking a by 4 the other way around, the sense this is a. So this is not the case, what I am actually seeing is, so this is what the case, right. So now there are several choices, right. So where omega 1 and omega 3 are actually a positive, in the sense you can see they are positive, and omega 2 and omega 4 if I actually take the other direction, in the sense I am taking all are actually equal, but omega 1 is omega and this is equal to omega 3. So omega 2 and omega 4 I am taking minus omega. then you can see like it is happening, right? In the sense you also like you see, so I am saying this is 4 by A. So this is omega 1 plus omega 2 plus omega 3 plus omega 4. This is also like fulfilling, right? This becomes 0, right? So that is actually like straightforward. You will get actually like this become 0. So in the sense, but what happened to our equation? You can actually like recall here. If I put omega 1 is actually like omega, omega 3 is actually like you can say omega, whereas omega 2 is minus omega and omega 4 is actually like minus omega. So in that sense, if I see that way, so what I will get, these two would get cancelled, right? So this would be minus omega, right? So in the sense this become plus and this would be minus omega and these two would be again getting cancelled. So in the sense what one can see from this, so if I actually like take this configuration, okay, I will actually like say the vehicle move upward or downward. Now one wanted to have a rotation about its own, clockwise or anti-clockwise, you look at this. So you look at this, what you wanted all in same direction, right? So in the sense omega 3 and omega 4 I put actually like negative omega, these two are actually like positive omega. What you can see, this would be positive in the sense whole negative, in the sense it would be rotating clockwise. But in the other case you can see like omega 3 and omega 4 are actually like you can say same. So this will get cancelled, this also will cancel, and this is just omega 1 to omega 4 all are simple addition. Any of 2 are minus and 2 are positive, in the sense you will get it, right. So now you want the other way around, you want to actually like rotate the you can say anti-clockwise direction. So you put you can say omega 1 and omega 2 are actually like minus omega and omega 3 and omega 4 are positive. So these are the cases now we are trying to simulate in the MATLAB, okay. So you can actually like try to see that. So I am just moving to the MATLAB window, okay. So now what we are trying to see, so we are trying to see as I'll just use it a new file just for our benefit. So I am just writing this is Magnum wheel, okay. So now Magnum wheel would be having 4 omegas, so omega 3 and omega 4, right. So now obviously you have to see the left, right and all. So I am not writing that way, just for my understanding I am writing omega 3 equal to 0.5, so 0.5. So probably I can take all the things are same at the initial, okay. So now what would be the W? W I can rewrite here. So what would be W? This is A by 4, right. So this one is actually like 1 comma 1 comma 1 comma 1, that is what you got it, and the other one is actually like 1 comma minus 1. You can just recall. So I will just show you after typing this. Then what you got it, this is minus 1 whole divided by, so D minus L, right. So the similar sense I will actually like take it, so D minus L. So you can actually like see the purpose, right. So that is what the whole idea here. So now even you change the different, you can say the Magnum wheel configuration. So you can actually like rewrite this equation and come back, right. So that's what, for example, now we have taken diagonally both you can say are in the same axis, right. So I hope I have seen there is a multiplication missing, okay. So now this is done. So now if I actually like run this, it definitely work, but I need to actually like change the parameter here, because here D is given but the L is not given. I am saying that L is probably 0.3. The sense here I will write just for benefit, I am writing this is 2D and this is L as actually this is 2 into L, you can say V, okay. This I will write as W just for consistency, then I have to write it everything as same way. You see this animation part also like we have used L, so I do not want to change so that it would be easy for you. So now this is what we derived in the lecture 8 and this is what we discussed even in the part 2. So now I am actually like redoing just once. So I am just taking this is 0.4 is the width and 0.6 is the length, just assuming it. Okay. So now if I actually like run this, so it would actually like go in a pi by 4 direction. So just to show that it is going forward, just for your understanding, I am putting that 0. Now all 4 are actually like same speed. So then what we have seen in the you can say discussion, this if I give all 4 are same speed and same direction, then that would go forward, right? We'll see whether that is happening. Yeah, it is going, right? So this is actually like a very good. So you are actually like achieved. So and it keep on going because we have given the time is actually like 100 second. So that's why it is keep on going. I'll just reduce it. So now I just try to show this again. Okay, my resolution still not changed. So you can see that this is the vehicle going forward, right? So now what we have seen, if vehicle wanted to go in, you can say lateral direction, the diagonal wheel supposed to have same speed but opposite direction, right? So in the sense I am putting it, these two are actually like opposite. So now what one can see, this can actually like give you can say lateral direction, that's what you have seen earlier. We'll see whether that is what you obtain, right? So now if I actually like change the direction of these two wheels, so this I put plus and this I put minus, so that would go downward, right? So now you can see like this also done. So now I want to have a clockwise rotation. So then these two are actually like negative and these two are positive, right? So that is what going to happen. So then it would be anti-clockwise rotation, I hope. We'll see. No, it's a clockwise rotation. Okay. So that we can actually like cross check. I think the here only we were discussed, right? Yeah. So you can see like omega 1. So omega 1 and omega 3 are same, but omega 2 and omega 4 in the opposite direction, that would give lateral. But in the other way around, if you take it, so this will actually like give clockwise and anti-clockwise. So now this is actually like what we have done as a clockwise. You want to see even anti-clockwise, you can actually like run it. So you can actually like run this. So now it will actually like rotate in the other opposite direction, right? So now it is actually like rotating in the way. So like that you can actually like get it. So now what you wanted, you want the diagonal movement, then you can see what you wanted. So u and v only supposed to there. So you are what you call the r should be 0. So then what combination you can put it. So you can actually like see, even if I take only 3, so wheel 1 and 3 is having a, you can say angular velocity, and these are zeros. So what one can actually like expect, so it will actually like do something, right? I'll just try that combination here. You can see, right, it is going diagonal. So like that you can actually like play your variation and then actually like you can move again. So now we will actually like come back to the, you can see the slide what we were actually like discussed. So now based on the, you call this particular configuration, you have seen like how the kinematic simulation can be benefited, because these 4 wheels are actually like what you can see. So these are actually like Magnum wheel, you cannot directly get the understanding. So that's why if the kinematic simulation is exist, then what one can actually like see it, you can actually like make more beneficial by varying the parameter and do it. Right now we have taken L and D, even you vary L and D, you can get it. Similarly, you change the wheel radius, you will definitely get it. And now you just replace these wheels. I have interchanged this, what will happen? So if I interchange this, what will happen? Or I take all are actually like same directional wheel, what will happen? These all combination you can do in a kinematic simulation. So that is what the whole idea about this particular, you can say the lecture 10. So now we will actually like move forward, I said already. So I will give one simple example where the special drive. So I will just give that example and then we will actually like move forward. So I will actually like see that how we can do it. So I am taking one of the simplest configuration. So which is actually like I take a, you can say a rectangular box as the vehicle, and I am taking a 4 caster wheels which are actually like a spherical caster. But what I am trying to do, there is a, you can say powered and as well as you can say rotatable way. Okay. So similarly I am taking this way. So there are two wheels which are actually like powered and as well as rotatable. In the sense you can see this theta 2 and this theta 1 are actually like playable, in the sense this wheel what it is giving A1 and omega 1, this is giving A2 and omega 2. I can decompose into what you can see x and y. If that is the case, what you can see, so this particular model what I have shown, that may not be workable. So what that model we have seen, so you can actually like recall this particular, you can see the file. This model won't work. Why? There is no passive roller. Further, there is no need of actually like finding omega, because the omega 1 would be actually like drive, but omega 2 would be actually like steering angular velocity. In that sense, this cannot become. So similarly, omega 3 is the drive and omega 4 is actually like a steering. So this combination I cannot incorporate in the generalized wheel model. But what I can do, I can bring it this as xci dot and yci dot. So then what you can see, this is, you actually like merged this. So this equation won't come. So now this is equal to what you call xci dot and yci dot, right? So now this is what important. So now if I know this equation, I can actually like do it. So I will come back to that slide where, so you can see that omega 1 and omega 2, I will write omega 1 and omega 3 are drive angular velocity, I call drive velocities. Okay. So that angular is actually like by heart, but still for understanding. So omega 2 and omega 4 are steering, okay, angular velocities. So now we will actually like see further what the equation we have. I assume that this is C1. So xc1 dot and yc1 dot would be equal to, so cos theta b, okay, here 1 minus sin theta b 1. So sin theta b 1 and cos. So this is the first matrix, and then you have actually like, so u v r, okay. So then what you can see, this is 1 minus this is dy. I will actually like cross check, because sometime the notation I might have used differently. So this is the case, yes, I have used rightly only. So then what you can see, this is 0, 1 plus dx, right. So these are actually like ith one, so this is 1, so this is the case. So now if we are actually like doing it, what you will get, so the, you can say projection velocity, in the sense you can see this, so I call xc1 dot and this is actually like yc1 dot will get. So now what you can see, so I can make this equation as like this. So xc1 dot, yc1 dot, xc2 dot and yc2 dot I can write. So now this I can write as a bigger matrix into what you call UVR. Now I take this inverse, so that is equivalent to what you call W into omega, okay, equivalent, not exact, as a zeta. So the zeta is actually like W into omega, that way I can write, but here it is not direct, but I can equate very close to that. So this is what I know and this is what I wanted, I can actually like use this equation, right. So this is what I was saying as actually like one of the special case. So what I can actually like do it in the next, you can say when we are doing a dynamic simulation, I can show this kinematic simulation also all together, okay. So then you can actually like understand where I will bring even the synchro drive motor. So where the synchro drive, in the sense you have a, I will just add it one more page. So where there is a mobile robot, okay, there is actually like 3 wheels, I assume that there are 3 wheels, okay. All the 3 wheels are actually like connected together, and whenever I am actually like moving in particular direction, all the wheels are actually like going to configure at that same way, okay. So in the sense all the wheels are actually like aligned in that direction. So in the sense this would be having 2 inputs, okay, one input for the drive, so the other input to orient all the wheel in the same direction of orientation. So in the sense what happened, this is very close to your you call the rotating chair. So when you drag the chair, you can see that by looking the bottom, all the wheel would be aligned in the direction what you are applying the force. So that is what we call synchro. It is synchronized. So synchro drive. So synchro drive actually like will come with minimum 3 wheel, even it can go 4, 5, 6 and all. But this is one special case which I cannot actually like derive straight away the model, because it is having a two things. One is actually like the drive, okay, other one is actually like synchro drive, which is actually like try to synchronize all the three. And if you look at it, the same motor would be used for both. That is the speciality on the synchro drive mobile robot. So at a time, for example, now you want to take a lateral turn, or you can say you want to move in a lateral direction. What the synchro drive will do, first it will actually like rotate all the wheel in that. So the same motor will actually like rotate all the wheel. After that, what it will happen, it will actually like come back. So now the drive will run. So in the sense, so for example, you want to move in the lateral, so all the wheel will actually like align like this. So now the second part or second step, you will give energy and then it will move forward. But there is only one motor. That motor would have a switching. So that's why I call it's one of the special case, which is what we call synchro drive. So similar way, what one additional special drive I can just add it here, which is what you call unicycle, where only one wheel, but that wheel would be actually like can rotate and as well as you call move forward. Since it's in a one wheel drive, so you can see like it can actually like rotate and move. It's very close to you call differential wheel, but in the sense differential wheel drive, the other wheel will actually like give a infinite resistance, but it is steerable, right? So then it can actually like maneuver wherever you want. So that is the idea, so which you call unicycle. So you know bicycle, but this is a unicycle. So unicycle is only one wheel and it would be maneuver wherever you want. You would have seen in the circuses and all, where one of the you call you can see like a clown. So he would be like moving in a one wheel cycle and he will maneuver wherever you want, right? He wants. The same way what you have done in a mobile robot, that particular thing what you call unicycle. But the unicycle usually come with a spherical wheel in order to give the you call zero friction on the lateral direction. So which is nothing but a spherical wheel where there is a you can say power involved. So one will actually like powered in the forward direction, the other one is just to rotate the wheel. Okay. So this is what for this particular lecture 10, where the part 3 also done. So what we have seen in the lecture 10 overall from part 1, part 2, part 3, all the kinematic simulation. Why this kinematic simulation is important? You can understand, already you might be knowing. So how the individual parameter will play in the overall performance. That is what you call simulating or analyzing the system, right? Now you take the wheel size as probably given in the catalog, but you are not getting that particular velocity as the longitudinal velocity, then you can go to other, you can say wheel, or you change your motor. In that sense, you can see like you are coming into a design aspect. So this is what important. So that's why this lecture 10 is actually like mean to put it here. So now we will actually like move real side, in the sense we will bring the inertia. So far we did not brought the mass or you can say material of the vehicle. So now we will bring the inertia, that means we are still in the rigid body but dynamics. So that is what the lecture 11 all about. We would be actually like covering all the dynamic aspect of the wheeled mobile robot, in the sense land based. So that is what we are going to cover in lecture 11. So we will see more aspect in lecture 11. Until then, bye. Thank you.